All right. It's 10 minutes past, and it's time to get going with this session about advances in CDIO. My name is Anders Rosen. I work at the KTH Royal Institute of Technology in Stockholm, and I will be sharing this session. So we have 3 papers in this session. The first paper, submission number 18, Development of Student Sustainability Awareness, Attitudes and Actions. The second paper is submission number 63, Choosing the Right D for Design. And then the last paper, submission 79, An Innovative Approach to Interdisciplinary Education Through Domain Sector Courses. I invite Syed Mohammed Soleimani as the first presenter, and I will share my screen and run the presentation. And we have about 1 hour for this session. The presentations are 7 minutes long, and yeah, we go for some 10 minutes for the questions and answers, and then yeah, we make use of the time that we have.
Hello, and welcome to this talk about development of student sustainability awareness, attitudes, and actions. My name is Syed Mohammed Soleimani. What is educating for peace? Well, it aims to foster the necessary knowledge, skills, and attitudes that cultivate a culture of peace and a prosperous society. Peace education should be integrated and mainstreamed throughout any educational experience provided in the educational institution. In an effort to promote a more peaceful living overall, the United Nations developed the Sustainable Development Goals, SDGs, with the aim of meeting these goals by 2030 in order to protect the planet and create a peaceful, prosperous, and sustainable environment for people to enjoy. As an example, SDG 4, which is quality education, focuses on assuring lifelong learning opportunities for all people and facilitating high-quality education for a sustainable built environment. We wanted to see how a student's perception of the SDGs were affected after completing an engineering project. To do this, we measured their perception of knowledge, attitude, and action before and after completing the project and compared to see the difference. We gave the students a questionnaire to fill out before and after completing their project. It included a question for each of the 17 SDGs for each of the 3 metrics, 51 in total. Here is a sample of the 3 questions related to SDG 1. Afterwards, we counted the students' responses and recorded the mean, median, a standard deviation, and performed a significance test. Here is a summary of the significance testing results obtained from the surveys. From this, we can make some inferences. Some SDGs returned negative values for the knowledge t-test, which means they haven't improved. This is in contrast to all other SDGs which showed improvement to some degree. The most significant improvements were noticed in these entries. In the attitude section, no SDG retained significant improvements. The highlighted SDGs show no improvements. Similarly, in the action section, we see the highlighted SDGs, a majority, have not improved at all. However, these SDGs showed a significant improvement. These results can help us interpret the mean results. Let's take a look at them. The following graph shows a comparison of the mean values of the knowledge section of the SDGs before and after completing the project. Based on that, we see that the knowledge of SDGs 4 and 13 did not improve after completing the project. We also see that knowledge of SDGs 1, 2, 8, 9, 15, and 16 improved significantly after the completing of the project. The following graph shows a comparison of the mean values of the attitude section of the SDGs before and after completing the project. Based on that, we see that the completing the project assigned to students had no significant improvement in the attitude towards the majority of the SDGs. In fact, completing the project had an adverse effect on some of the SDGs. The following graph shows a comparison of the mean values for the action section of the SDGs before and after completing the project. Based on that, we see that the action towards fulfilling SDG 9 and 17 has significantly improved among respondents. It is worth mentioning that the engineering project assigned to students in this study was aligned with CDIO pillars 3, 4, and 8. So, what did we learn from the results of this study? We learned that the CDIO approach can significantly improve the knowledge of students related to SDGs. We also learned that knowledge of the SDGs can be impacted and improved in a relatively short period of time. We learned that unlike knowledge, the attitude and action towards SDGs cannot be significantly improved in a short period of time. We learned that the effect of gaining more knowledge about the SDGs may or may not correlate with seeing more action and attitude in the SDGs. In fact, the effects could be either positive or negative. In order to get a better understanding, we need to conduct this study over a long period of time. Thank you very much for watching my presentation. If you have any questions, please write them down in the chat box.
Thank you very much, Syed, for an interesting presentation. The floor is open for questions or comments or discussions. So you can use your raise your hands, for example. Ulrika Lundqvist, you're raising hand. Welcome.
Yes, thank you. Thank you for the presentation. I would like to know if you could tell me more about how the SDGs were integrated in the project. How did the learning situation look like for the students?
Actually, what we did, we introduced a very short project over 6 weeks. And obviously, we cannot really cover, to be honest with you, we cannot really cover all 17 SDGs in depth in this short period of time. But what we did, we created the questionnaire, and before the project started, they answered the questions on 4-point scale. And then after the project finished, they also answered the same questionnaire again. But during these 6 weeks, actually what we did, we asked the students to, we discussed the SDGs in the classroom. And also we asked them to reflect on these SDGs and have some sort of group discussions and get a better understanding and deeper understanding about the SDGs. And definitely the project can, it's very hard to find a project that can cover all 17 SDGs. For example, in our project, we were touching maybe 3 SDGs out of 17. But because we had fruitful discussions in the group in each classroom, I believe that this also helped the students to understand the concept more. That's why you see that out of the 3 main pillars, the knowledge increased significantly in all areas, because really in 6 weeks, that was one of the main reasons to conduct this research, to bring this knowledge and awareness to students in the region.
Thank you.
Thank you.
Any further questions or comments? Floor is open.
I can ask another question if that's okay, if no one else.
Perfect. Go on.
Yeah.
Sure.
I also would like to know, how did you formulate the learning outcomes for the students? What were your expectations? What did you want to accomplish? I think you showed something, but it went a bit fast in your presentation.
Yeah, actually, this is a part of a course. You know, it was a project within one of the project-based learning courses that we are offering in the School of Engineering. It's a multidisciplinary course that we offer to students in civil and mechanical engineering. And the learning outcomes is related to this specific PBL course. It's not related to this specific project. One of the main reasons that we introduced this, because we wanted to have, because we had, I think at that time when we conducted this research, we had 7 classes of the same course, because it's a multidisciplinary class. We had lots of students. That's why we said that we should use this opportunity and use this large number of students for this study.
Thank you.
But if you want, I can share the learning outcomes of the course with you in an email, or the course outline with you as well, if you want.
I think it's interesting, Syed, that you are looking at knowledge, skills, and attitudes, or you're looking at knowledge, attitudes, and you call it action. And you are, I think, concluding similar things as we see in many places, for example, at KTH, at my university, when we have evaluated the integration of sustainable development, that many teachers are focusing on developing the students' knowledge about sustainable development, but to develop the students' abilities to actually do sustainable development and their attitudes. That is happening to a much lesser extent. So I think that's a contribution from your paper to pinpoint that to develop knowledge is one thing, but it's important, but it's not enough. Our students also need to be able to take action, and they need to develop their values and attitudes. Why should we bother about sustainable development, and what is the implication of our work as engineers? I think that was interesting. I'm a little bit curious on how you're going to take this further now. Do you have any plans for enhancing your teaching and your courses regarding developing students' sustainability action, for example?
Actually, what we are going to do, hopefully after we go back to the normal teaching face-to-face, what we will see most probably from this September, we will go back to face-to-face. Most probably we will introduce specific projects, and in those projects we will concentrate on some specific SDGs and evaluate the students' knowledge and attitude and action in those specific SDGs that are 100% related to that project that we are going to offer to students in that semester. Also, I wanted to add to what you said, that you saw that in actions and attitudes we had some negative effect after the completion of the project. In my opinion, because at the beginning, maybe as students, they were very enthusiastic, and then they thought that they can do the actions, and the attitudes are easy to be changed. But after the discussion, after 6 weeks, they realized that everything comes with a cost, and it's not really easy to implement. You can be very optimistic and say everything will become very normal, and we solve all the problems in the world in a short period of time. And then after 6 weeks of these discussions, they realized that the action is not that easy to be implemented.
Yeah, that's an interesting observation, and maybe it's related to your research method here, that you're basing this study on the students' self-evaluation. And then when the students' awareness raises, they judge their knowledge and skills lower than they did when they were less aware, so to say. So one thing to consider is to make this kind of study by use of qualitative methods, maybe making deeper interviews or working with focus groups with the students, where you actually in more depth can explore what skills and attitudes do they have, actually, not just how do they judge their skills and attitudes. And maybe also if you could implement that in the learning activities and in the assessment. So thanks a lot, Syed. We should continue this session with the next presenter, Joseph Foley. The presentation or the paper is entitled "Choosing the Right D for Design," referring to the D in CDIO, I imagine.
I haven't actually tried playing audio through this computer on Zoom, so this will be an interesting experiment.
You sound perfect.
Well, that's my headphone. I haven't tried playing video sound.
Okay, but
Let's see here.
The host will help us with the video, I think. So.
Oh, is the host playing the video?
Yeah, the host is playing the video. So.
Okay, very good.
Yeah.
Let's make sure it's the right video. That will help a lot.
Well,
thank you.
Paper presentation for the paper Choosing the Right D for Design. My name is Joseph T. Foley, and I co-wrote this paper with my colleague Marcel Kias, and we are both professors at Reykjavik University in Iceland. The CDIO v2.1 standard says that you need to do design as part of the conceive, design, implement, and operate process. And it says that it recommends that you teach about design in Standard 1 and that you provide design exercises in Standard 4. But it doesn't go about telling you a lot of how to implement design or even what design really means. So we wanted to explore, how does one pick the right design method within the CDIO framework? This is because design is often taught as simply iterative tests, but there really are many approaches and methods out there. Our motivation came about through teaching 2 courses. They are Introduction to the Internet of Things with Marcel Kias and Mechatronics 1, which is the course I taught. Both of these courses are cross-disciplinary courses incorporating elements from computer science, electrical engineering, and mechanical engineering. In both of these courses, you need to design a system, be it an internet-connected system or a mechatronic system. This means you need to incorporate physical components, some sort of thing, software to glue it together to make communication on the internet, and at the end, there needed to be a prototype demonstration of the concept. On the right, you can see images of Waldo, an in-wall humidity monitor for the home developed as part of the IoT course. This device was designed to be mounted to a wall so that homeowners could detect if moisture was developing on the inside of their walls. This moisture could be turned into a mold infestation, which is a particularly bad problem in Iceland. There are a variety of popular methods for design. 3 of the ones we explored are below. The Google Sprint method is particularly popular among computer scientists. This is a time-boxed method, which is to say that you have 5 days to design, prototype, and evaluate, and a very specific schedule of what you should be using those 5 days to do. At the end, you end up with a sketch prototype sufficient for trying to gather more resources or to pitch an idea to do investment. In Axiomatic Design, which was developed by Nam Su of MIT, you are trying to solve mechanical issues primarily, but it can be extended to generic design processes. Axiomatic Design employs 2. Indicates that you need to keep your requirements independent of each other, or in short, make sure your system is sufficiently that you should choose components and combinations with the highest chance of meeting those requirements which are now independent. And in another way of saying, you are trying to choose robust combinations and components that always meet their requirements or have the largest number of environments where they do. Finally, the third method we used is called product design and development, which is from the same named book by Eppinger, Ulrich, and Wang from MIT. And this is a customer/stakeholder focused system with business intent, which is to say there's a lot of communication between the developer and the customers in order to figure out what would be the concepts that make sense and develop them into sustainable approaches that could be turned into a startup or a research project. We realized as part of this investigation that these mechanisms all harmonize together. Conceive, design, implement, and operate create 4 phases as part of CDIO. Conceive maps very well to Axmac Design's customer domain, which is gathering of needs. The design maps very well to Axmac Design's functional domain, that is gathering of requirements. The implement phase maps very well to Axmac Design's physical domain, where design parameters are chosen. And finally, the operate phase maps very well to Axmac Design's process domain, where the variables that affect the operation of the system are explored. In addition, the product design and development approach has the same sorts of mindsets, but it also has transitory positions. So there's a planning phase, which leads to a concept development phase, which leads to a system level design phase, which straddles design and implement, to a detailed design where the specific components are chosen, testing and refinement, which is in order to see whether or not they meet the requirements previously specified, and finally production and ramp up, which is the technology transition required to turn it into a sustainable business or a research project. In addition, as part of this investigation, we discovered that sometimes those methods were not good enough, and to that end, there are hybrid methods. These include the collective system design approach developed by Cochrane, and this is a customer-involved graphical Axmac design approach where they use the graphical method to indicate the interaction between requirements such that it is more approachable to a larger audience. Over at Chrysler Daimler, they use a mixture of Agile and Axmac design in their design and development department called ADAPT, which they use for developing new mechatronics, new fixtures, and new parts of cars. In Reykjavik University, we use Sprint and AD in the Internet of Things class to great success, and in the Mechatronics 1 and Design X course that I teach, I use a mixture of product design and Axmac design. One of the results of the Design X course approach is on the right, which is a mobile power line monitor called the Line Dancer. And this is designed to be easily mounted and unmounted from high tension power lines in order to measure temperature and determine if the line is in danger of sag. To summarize, the CDIO standard is very open on design, which is very much an advantage, but it comes with also its disadvantages in that there is not very much guidance on how to implement this. The authors suggest exploring a variety of design methods because there are many, and then choose a design method appropriate for the task or the project. We have found that Axmac design is suitable as a good generic method to start with. But if you are trying to do something fast or are in the early exploration phase, the Google Sprint method was also very nice because it has very specific time guidelines that indicate when the process will end. Some disciplines may have different traditional choices, which also must be taken into account. And finally, if none of these are suitable for what you want to do, choose a hybrid method where you take the best elements of each of the other design methods. This is particularly appropriate for cross-discipline projects. These are the references that are discussed in the presentation. Thank you for attending my presentation.
Thank you, Joseph, for an interesting presentation and interesting work. I've seen many CDIO design projects which are basically not making use of any design methods. It's only based on the students learning by doing. So I think this is a really good contribution, showing that what are the options in terms of specific design methods. And I think also this with combining different methods, these hybrid methods, is really seems to be the way to go, I think.
Thank you, Anders.
The floor is open for questions and comments to Joseph.
I have a question. Oh, go ahead. Please.
Jaroslav?
Thank you very much for this presentation. I have a kind of short question in regards to this figure which you've shown on the mapping of CDIO to axiomatic design and Eppinger. I actually, when I was reading the proceedings, I found it very, very fruitful, this figure. Thank you for this. So the question is, did you try to see what is the fraction of the transitioning elements when you see the concept development, for example? It is at the intersection of conceive and design, right? So did you try to see that, well, it's more in conceive or more in design, or this was not part of your study and that's something for the future work?
Well, so an important part to note here is that it looks very linear, but this is a lie. In many of these steps, you are looping back as necessary to take information from the system level design and feed it back into the concept level design. So that concept level, concept development transition actually kind of shifts. And it's actually really both in the conceive and design element as it's taught in the Eppinger book. So they tell you to do concept development in the conceive phase, and then you do it again in the design phase. And honestly, you do it again in the implement phase. And in each of these steps, those are feedbacks to the customer to help you design a better concept. So basically, you have a pretty good idea for the concept by the time you have transitioned to implement, but sometimes you end up going all the way back. Design is by its very nature an iterative process. What we learned that was very useful was that if you have design methodologies, they tell you when it's a good idea to go back and when you can just move forward. So axiomatic design is very big on very limited amount of iteration, and product design development is big on lots of iteration, but very small, cheap iteration.
Yeah, thanks a lot. Thanks a lot.
Ola, did I see you raising your hand?
Yes. Thank you very much for your presentation, Joseph. I was wondering who are involved in these different stages. Is this design activity merely an engineering activity, or is it an activity that involves other participants coming from an area where participatory design methods, well, they exist and some use them and some advocate for them ferociously. I wonder if you considered methods of design that involve many or few different kinds of stakeholders.
Well, so this is an interesting point, because in axiomatic design, they say you have to have stakeholders and then gives you no guidance. So in fact, one of its weakest parts is that customer phase, it gives you no help. So that was one of the reasons, since I'm a researcher in axiomatic design, that I got interested in the product design method, is because it spends a huge amount of time on the stakeholders and the customers and developing their needs. It's like 3 chapters in the book. And so from a product design element where I come from, there's a huge amount of both communication and interaction with sometimes one stakeholder, sometimes it's a huge number of stakeholders, and you have different approaches for each of these, and these are discussed in the books. For instance, in some cases you do one-on-one interviews, in other cases you do video interactions, in other cases you send out pamphlets and you get feedback, you do surveys, it's all in there. So that's one of the reasons why I found for my teaching, my multidisciplinary courses, where you're trying to make a prototype, that I needed both. I needed the product design in order to teach students how to talk to customers and decipher the crazy stuff they say. And then I needed axiomatic design to keep them from getting stuck. Because if you just follow the product design method, it's very easy at some point to just spend all your time developing concepts. It's a trap you fall into. Whereas axiomatic design, you don't have that happen. Basically, you go through one iteration of it and it says, okay, here are the 2 concepts to explore. Probably this one has a higher chance of success. So iteration is very minimized in axiomatic design, the middle row, and the bottom, it's much better at understanding the early phases of what you need to do. So I subscribe to a hybrid approach, as is mentioned in the presentation. I hope that answers your question.
Fair enough.
Thanks. Are there any other? Clement, did you have a question? Please.
Oh, we can't hear you, Clement.
Please unmute.
Oh, okay. Do you hear me now?
Yes,
now
I can.
We hear you.
Good to see you.
Okay. Hi, Joseph. I was wondering, did you manage to get to the testing and refinement and loop on this? And is this a strong part? And how do you mix it with axiomatic design? Because I think if the stakeholder is not their axiomatic design, I don't see any link also to testing and refinement, which is a very, very important, and it's more of the agile approach than anything else.
So you're right, Clement. In traditional axiomatic design, the testing and refinement is just missing. But that's, again, the reason that I integrate now this teaching of generic product design development is because it talks about it a lot. So if you merge the two together, it does a great job. And this is actually in some ways what collective system design did, was it said axiomatic design doesn't help the implementer as much. It helps the designer, but when you get to the actual doing it, what are you supposed to do for testing? And so if you follow collective system design by my colleague David Cochran, it says each requirement and each implementation design parameter needs to have a metric, which is effectively a tolerance. So once you have those metrics and tolerances, then testing and refinement becomes possible, because you can say, yes, it met it, no, it didn't meet it. So collective system design, honestly, is much better at that than axiomatic design is. Product design development, back at the concept development phase, you are forced to benchmark other products and build a metrics table. And then you use that metrics table to figure out where you are going to innovate. So are you going to make it stronger, faster, better, cheaper? Which are the things you're going to put your resources into? And that feeds very nicely into axiomatic design as a set of either requirements or constraints, which then helps you with the implement phase. So these two things really merge very well together, because the product design tells you to go see what other people did. Interesting enough, axiomatic design at the beginning tells you not to see what other people did, because it doesn't want you to get your ideas what do you call it? Go in with pre-existing ideas. A big component of axiomatic design is you should be developing requirements in a solution-neutral environment, which in many cases means going in knowing very little about what's possible or impossible, and you don't actually start going in that until the implement phase. So for teaching my students, I often find that they just can't do it. They want to know about what they are studying or designing before they design it. And that kind of makes sense to me, honestly. So that's where the product design approach gives us a much better idea of figuring out, okay, this is what the industry does. This is how they test it. And in fact, in the product design book, it even tells you to go do the test yourself. And then you take those tests and you repeat them again in the testing and refinement phase of your product. So by the time you've hit that phase, you have developed both requirements and metrics, which you can check to make sure your product does it. So it's very satisfying when students do this right, because they're like, why am I spending all this time up front getting all this information? You say, all right, now we're in week 10. Remember all those things you did? Now we're actually going to use them again. They go, oh, I get it now.
Okay, good. But which part of this do you find students have the greatest difficulty? Or it's all...
Let's see, greatest difficulty. Probably system level design, honestly, because they're good at making the individual pieces, but they're not so good at necessarily communicating about how they connect together. So it's the integration. So integration, as we well know, is both multidisciplinary, communication heavy, and in many ways the most complicated, because you have to, unless you have discussed interfaces between the modules, which again, axiomatic design's axiom 1, except I think the audio cut out, is all about modularity. So if you do modularity well, then you have to define these interfaces. And by forcing you to define these interfaces, you can make it so that your chances of integration go better. Not guaranteed, but the more modular something it is, the more easy it is to realize, oh no, module B doesn't work, throw it away, put module C in, connect it. Okay, that worked.
Okay, thank you very much. Thanks.
I have one question here before we continue with the next, connecting to the first presentation in this session, which was about sustainable development. And we are, when we're looking at sustainable development, we are extending the system. You said that the students have difficulties in connecting the different parts within the technical system. But what about the interfaces to the larger system, to the planetary system, and to the social system? Do we have any thought about that regarding?
Well, the product design book, as you might guess, does discuss that. It talks about intellectual property. It talks about the economics. In fact, there's even a chapter on sustainable engineering. So it talks about materials choices and disposable and life cycle analysis. And as part of the DesignX course, I forced them to go through a life cycle analysis. So that's one of their assignments, is for the product they're designing, figuring out how are you going to dispose of it when you're done, and or how long does it last. I mean, so from a greater circle point, we do have a problem that Iceland is an island. So we tend to think very locally. And in fact, it is sometimes very challenging to get students to look outside of our little circle. That said, the students who have great ambition often shoot for too big. They're like, I'm going to make the best thing, blah, 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 ever. And you have to, as a teacher, say, that's a great vision, but we don't have the $1 million necessary to do that. What can we do with the, $1,000 we have? And so we have both. So we have students that want to shoot for the stars, and we have students that are like, I just want to make a better fishing hook. Both of them have their places, and it's exciting to teach the Design X course because you see both of those students, given the right tools, they will design a better fish hook, and they're going to design a better rocket. That's why I highlighted these two projects. So the Line Dancer is a project that started out of a local need because in Iceland, much like in Norway and Sweden, we have a problem with the temperature of the power lines causes them to droop, and then you have a big problem. So we were consulted by a drone company who was working with a power line company that said, hey, could you make something so that we could take a drone, drop it on a power line, measure the temperature for 2 days, and pick it up later? And we said, actually, that doesn't sound too hard. So we spent 15 weeks, the first 12 weeks learning the design processes and doing some early design stuff. And then the last 3 weeks was this intense design phase where all they did, they had no other classes, they just worked on this project. So I was very proud of them for developing this because this project will actually be presented at another design conference later this week because it was the most successful project of the entire set.
Thanks a lot, Joseph. We continue with the next presenter. So I invite Jaroslav, and I ask the host to please play the next presentation.
Dear colleagues, it is my pleasure to present to you today our paper entitled An Innovative Approach to Interdisciplinary Education Through Domain Sector Courses within the
hello,
conference.
host.
This paper has been written by myself, Dr. Yaroslav Menshinin, and Professor Clement Fortin from Skolkovo Institute of Science and Technology. And it's our great pleasure to be with you and to present this work. Let me start with the background. And the sector courses, as we define them, are aimed to cover the specific industrial sector through the providing a holistic view on this sector from a variety of engineering and business perspectives. So that's how we define this sector course. In this work, we are emphasizing the experience that we got through the 3 sector courses offered at Skoltech: Space Sector course, Power Market course, and the Product Development and Manufacturing course. We'll dive into the Space Sector course as the case study. All of these courses are the master's or PhD level students with 6 ECTS. They taught at Skoltech in English language. And as I've mentioned, we will study Space Sector course in details. Skoltech, in a nutshell, is a Moscow-based university that was founded around 10 years ago in collaboration with MIT. And since that time, we have a very strong and embedded CDIO approach in our education, including the systems engineering and other disciplines. The objective of our paper is to present a general framework for the sector course in any domain of interest. Such framework would include the core elements of the course and how, when combined together, these elements lead to the specific learning outcomes achievement. The practical utility of the paper is that it outlines the core principles of the sector course that is based on the CDIO approach. We also demonstrate the architecture of the course and consider the course itself holistically as a system and build the system models in OpCloud. Professor Dovdori developed the OPM, Object Course methodology, and we use it to just demonstrate space sector as a system. As I've mentioned, we've listed 3 courses that are offered at Skoltech and with the course descriptions, and we studied them, and then we decided as the methodology, we decided to go deeper into one of them, the space sector course, the one which we have the rich experience working on, and many times it's been run. It's Skoltech for master's and PhD students. So that's why we picked up it as the case study. And in this space sector course, we consider the space sector through 3 different lenses: subsectors, technologies, and organizations. And the figure that you see in the right-hand side of this slide reflects the space sector course in respect to the Skoltech learning outcomes framework developed by Crowley and colleagues. And these Skoltech learning outcomes, they built upon the CDIO principles. So you see that some of the sections and subsections are highlighted, so those which are reflected in our course. If you go further and we consider the sector course itself as a system, and if we follow the Ed Crowley's definition of the system, that this is a set of elements or entities and their relationships whose functionality is greater than the sum of individual entities, then we should say that in our paper we apply this definition to consider the space sector holistically as the system. We first outline the elements of the course, and at the next step we build the relationships between these elements. And then we see how, when all of them are combined, this leads to the achievement of the learning outcomes by students, so they get the knowledge and skills which are so needed in our world. So this diagram just is used to visualize what I've just said, that the space sector course is an instrument to acquire the learning outcomes that we've just seen in the previous slide for the Caltech graduate students. And the CDIO framework is an essential element to build this course, to build the syllabus of this course. If we go further, we will see that space sector course is decomposed into the cross-disciplinary lectures, sectoral courses, sectoral lectures, and assignments, and they're all interconnected. So the idea is that there is a connection, for example, between the system thinking and critical thinking lecture and the assignment one. So they should happen prior to assignment one, and this information from these lectures inform and support students in their knowledge to build a system map within the assignment one. As the discussion, this course has been run more than 5 times and was delivered for more than 120 students at Caltech. And the practical utility of the space sector course is that it helps students to shape a holistic understanding of the sector, and it can easily be expanded. We should not focus on space sector only. The idea is that we can go even further and consider the other sector courses as well, because those questions like who are the main stakeholders in this sector, how profit is achieved in this sector, which resources are critical for each stakeholder, and how the process of resources exchange is organized, all these are questions that are relevant to each and every sector. So sector course is a unique perspective to support students in acquiring knowledge and skills related to a whole sector's life cycle. So the sector course that we've presented is reflecting standard 1 of the syllabus of the CDIO standard 3.0, the context, standard 2, learning outcomes, standard 7, integrated learning experience, and standard 8, active learning. In conclusion, we presented a general framework for the sector course of any domain of interest. We focused on 3 of them, but we picked up the space sector course to study it in details and to build our discussion around it. As a case study, we discussed it. Upon successful completion of the sector course, students acquire knowledge and skills that help them to formulate the next innovative product and to present it in front of investors and other experts to defend their projects. Thank you for your attention.
Thank you, Jaroslav, for an interesting presentation. The floor is open for questions or comments. Do we have any questions to Jaroslav? Yes, Svante Gunnarsson, please.
Yes, thank you. Svante Gunnarsson from Linköping. This concept, has it been adopted in many other courses yet?
Thank you for your question. We actually applied it to, as I said in the presentation, to the space sector course, which has been run around 6 or 7 times since 2015. It's also been applied to the other courses at Caltech, which were run. The idea of the way that if relevant, I mean, we are looking forward to apply it and to adapt it for other industries as well, because we consider as the way to look at this kind of holistically, And this thing is very well aligned from my point of view with the keynote speech which we heard today, just earlier today, when we speak about the interdisciplinary education, right? Maybe that's a question whether we need to educate like the younger students, but if we are talking about master's degree and PhD level students, then from our point of view, this approach would be relevant because it would help people to see the sector, as I said, holistically, following the CDIO approach and systems engineering principles, and to embed not only engineering but also the business perspectives into how the sector operates and what are the next big thing in this sector. So if students want to kind of apply it in business perspective or engineering one. Thank you for your question.
Thank you.
Maybe a comment, Venti. You know, it's sometimes hard for students who only have a technical perspective to see initially the benefit of such an approach, because you mix in one course some technology, some and then markets and research and development, and so that and then also different experts to give them different views, which requires from them to adapt, because they have to learn to see, oh, what's the perspective of this? He's coming from another angle. What is this? So it's a demanding course into this, but some of the students are really able to fully benefit from this. And if we want to have some innovation component in our programs, I think that this is one very concrete way to bring it in one course. I did develop one version, and what it was only given once, but we're probably going to come back to this very soon, is that I did it for product development and manufacturing. And of course, this is a broad sector, so you obviously need to tell them, but I did it for PLM technologies, okay, so the digital part of on the product development side, and also on how does people understand, how does it transition to manufacturing. And so this is a whole world, right, that very few people have. So just like the space sector, I mean, it gives them an overview of the whole sector so that students don't have a clue of how this business is running and what are the financing of research and development and what are the perspectives of markets. Yeah, so this is it.
Thanks a lot. Anders, you have to unmute.
Thank you, Svante. Parang Vicharen, you're raising your hand. Welcome.
Hi, thank you. Thanks very much just want to know something about implementing this CDIO standard on your programs. How it is implemented, what is the time frame, how much time does it take when you start thinking about implementing this kind of framework for your programs?
Could you somehow a little bit repeat the question, please, because the connection was not good and I heard only part of the question.
Sorry, yeah, I can repeat. Sorry, it is, you know, I mean, we are thinking about implementing this CDIO framework for our programs, and that's why I just wanted to, you know, have your experience on, you know, what is the time frame really to implement this kind of standard, this kind of framework on your existing programs.
Okay.
Time frame I'm asking.
But Mr. Sava, there's something not clear here. Are you talking about this sector approach or the whole CDIO approach? I'm not sure what your question.
It could be, well, it could be a whole CDIO approach, but more specific towards, you know, what you're presenting, sectoral approach as well. What is the time frame?
Let me try to answer, and then we'll kind of narrow down the question if I answer not clearly and not in respect to your question. So in this specific course, we actually targeted some CDIO, the learning outcomes that are built upon the CDIO approach, right? So we make the focus on the knowledge and knowledge of innovation and entrepreneurship and the interdisciplinary thinking. So these are the things that are under disciplinary knowledge and reasoning. So we also make some emphasis on cognition and modes of reasoning, as well as attitudes and learning that are what's related to of course, students' acquisition of skills and knowledge as well. And also the communication makes a very important role as we notice that, for example, in Russia, we have a very pretty strong technical background that students get in the kind of bachelor level degree, right? When they just enter the universities after the high school, but then they are kind of stuck. They cannot actually somehow, promote their idea. They have the technical background, but they do not know how to present the idea that they have, and that's something what is needed, because they already have a good math, already have a good physics, but how to kind of convince other people or investors that they know it. So that's why the emphasis on communication and the kind of collaboration plays a very important role, as well as the leading of the innovative process. So again, people are very well aware of some kind of technical stuff, but how to help them to acquire those knowledge and skills that are related to kind of this more business and entrepreneurial perspectives. So these are all kind of CDIO principles and learning, the Skoltech learning outcomes that are built upon it. And hopefully this is answering your question, but if not, I'm ready to clarify.
Yes, I mean, it's a great take what you guys are doing. It's just something, how much time it took you to implement this thing? Is it like, phased approach in 1 year, 2 years, 3 years? How much time it took you to implement these all principles for the new programs or modules?
You mean how much time the course is running?
Yeah, that's right. How much time it took you to implement this new thing, this new principles in your programs?
It is an 8 weeks course, which is equivalent to 6 ECTS.
Right.
So it means like half a full week occupation, right? So, and it is run for 8 weeks as any other course at Skoltech.
Right. Okay. Thank you, Yaroslav. Cheers. Thanks.
Thank you, Parag. Thank you for your question.
Okay, so we are approaching the end of this session. I thank the 3 presenters for very interesting presentations, and all the attendances for interesting discussions and for your attendance. I encourage you to take contact with the presenters for further discussions and sharing of knowledge. So hereby we are closing this section, and now I think we have a break, 10 minutes before the next sessions get started. So thank you, everybody.